machine or talks to human or other way around, we call it user interface. But these systems are heterogeneous. They are the way a computer works from the inside and the way human process the information is very different to each other. So, and that difference is the problem. For traditional UI or interaction design paradigm, we have solved that problem. So how we do this? We basically know that human and computers are very different systems. In case of computer, we have an input. We have an input triggers a process, and the process produces an output. And for the most part, these are very definitive, predictive things. You know, you have a very definitive input which fires a transparent process. Essentially, you can open the hood and look at the like machine instruction, CPU instruction level, how the sausage is made, how it is being processed. And output is also very replicable. Now the thing is, that means you can reliably reproduce everything. That's the luxury we don't have when it comes to AI, and that's the reason we see that with the same prompt, you don't get the same result. So our input is more iterative. You know, so basically now we have two variable in the system, but again, we are getting ahead. When it comes to human, the input is essentially our perception, our sensory apparatus. We have a perception, then we process the thing, we call it cognition, and we initiate an action. Now the thing is, these are not reliably replicable systems. Your perception depends on a lot of things. How much food you had, whether you're colorblind or not, in what mindset you are, what's your training or prior exposure to the system. So as when the AI kind of gets the center stage, we are moving more from like computational analogy to human. And that's where a unique characteristic of human come into the picture. Humans are shaped by their experiences. And so in traditional system or the human in this case are shaped by their history, what they have seen, what the tooltip they have seen, and have they used the software before, have they used a similar metaphor before. That's how they are shaped. Now problem is we have essentially not the problem. The thing is that we have solved this problem in the traditional design sense. For a more predictive, more pre-AI world, this problem has been solved. And how we have solved that? We tend to find the common biggest subset of user, and we basically design for them. We find out what they understand, what we can make assumption about the user, and when we design for them and hope that rest of the people will automatically learn. You know, so what are the good interaction design principle in pre-AI world and how they are going to be disrupted? In pre-AI world, there are like 6 principles by and large which we follow for good interface design. The principle of empathy, principle of metaphor, affordance, feedback, material, and context. And we are going to race through them. Empathy. Everybody tend to think that they have the empathy toward user, but it's really, really very hard thing to attain. As a designer, when we tend to design something and user is not able to use it as expected, what we think that, hey, you know, this user is stupid, this user is not able to get, hasn't he read my PRD, you know? So the problem is that the moment you think this, you essentially lose the empathy. As a designer, your job is essentially to empathize and simplify. It's not user's job to basically learn and adapt. It's your job to empathize and simplify. And most designers sadly fail to do this. This example you can like, I'll provide the slide, you can go through it. The people are like asking, this is basic design flaw where the instruction to use this helmet was not given and people were criticizing the user. That's not how empathy works. And also metaphor. Now the problem with this thing is, how do you feel empathy toward machine? You know, or a system which is not like human. We struggle to feel empathy toward humans. Now the challenge is double. We have to feel empathy toward machine or an algorithm. Metaphor. Metaphor is that analogy, that template by which a user navigate a software. For example, in desktop, the metaphor was desktop computing. The metaphor was of desktop. you know. So we looked at the real world, we saw desktop, there is a file, there is folder, there is recycle bin, there is in tray, out tray in real world before computer existed. And we mapped the same mechanism, so it become easy for user to navigate. And that's the beauty of a desktop. That's the beauty of a metaphor, essentially, that people, when they get the metaphor, they essentially stop thinking about it. So one very interesting example is essentially in email and stream. If you remove the veneer of an interface and look at technically, both feed and inbox are essentially the same thing, right? They're aggregating a set of messages which is meant by us for a specific recipient. But we feel a pressure to check our inbox. We feel a pressure to reply to it, but we never feel the pressure to respond to a feed. Because our mental model is inbox is for me, feed is always flowing. News stream, it's a stream. I can put my feet into it, I can pull it out, but my it's not my responsibility to check my feed. That's how news feed is generated. And that metaphor kind of clicks, and that's how our behavior is shaped. So again, in terms of AI, what will be that metaphor? Operating metaphor. It's not really very clear. What is the affordance? Affordance is essentially a small clue. See, everybody tends to think that whatever interface they have designed, it's like automatically comprehensible. It's very intuitive, but hardly anything is intuitive in the world. So how we circumvent this problem? By providing some kind of physical or a digital cue. We look at a doorknob and we know whether we need to push this thing or rotate it. We look at a handle, we know whether the door need to be pulled or pushed. So that's the affordance in real life, and we have digital affordances also. The problem is the dominant mode of interaction in AI is voice, at least so far. And voice has infinite affordance. Pretty much anything can be done with voice. So user don't really know where to start. And that's the problem. Okay. Same is the feedback. Feedback is the way humans interact with machine and machine talks back to them. Now we have all kind of feedback the software gives us. It's a status, it's error, tooltip, tutorial, and like final update of the task. The problem is when the bad UX, the bad user design, user experience design happen when we fail to provide the right feedback. Essentially, when let's say if there is delay, more than expected delay is happening in uploading a file and you don't get the message is taking longer than expected, that's a bad UX because there's a failure of feedback. The problem is that whole feedback paradigm is also going to be disrupted by AI. Material. We tend to, in pre-AI world, we used to tend to design with workflows, set of rules, specification. In post-AI world, we will be designing with a material which is called human. The behavior is the material and emotions are the feedback mechanism. And that's make it far more complicated because we neither understand humans and we have very little understanding of how the emotion act as a feedback. And we expect machines to understand it. You know, we struggle as human to whenever there's emotive feedback, we struggle to process it. How will machine, how will Alexa understand the tone of voice when you ask them the third time to tell a certain information? Machines really gonna stuck, and we have to standardize those things. So these are the challenge, and in this set of practices which was very rigid, which were made for very, very binary, like Van Neumann architecture of computer, suddenly along comes AI. Now everything has moved. Now in previous pre-AI world, what we had was a static computing, a fixed set of algorithm on one side and a variable human on the other side. In post-AI world, both parts are dynamic. You have an iterative input, a human who thinks of something, think of a prompt, feed it into AI, which itself is a black box for the most part, we don't know. And we have to reach to a very reliable output and or at least give the right feedback. So how do we go about it? One way to think about this transition is to think about how do you navigate on a road sign of stop and caution. Up till now, the UI design was based on this metaphor, stop. There is no ambiguity. You are supposed to stop. A red color stop sign means no more trespassing this place. Uh, but in AI, everything is like a yellow caution sign. Now it's your judgment, you know. So how do you design? This is I think, a fitting metaphor. So how does this change? How do you basically, the design brief changes when you have to design not for stop but for caution? And that, my friend, is essentially a full stack of challenge. We have to rethink our interaction design on every level of stack, you know. So you have to think of hardware. You know, one of the interesting thing, as somebody who's been in industry for a while now, is this, and I've seen multiple shift in UIs. I started with like coding on machine language, zeros and one. I have done a bit of assembly programming, CLI, like your command line interfaces, GUI, touch screen, AR, VR, and all. So yeah, so don't be confused by my young look, I've done that. Now the problem is, this is for the first time that hardware is lagging. For every other iteration of a paradigm shift in UI, it was always hardware was the leading indicator and software did the catch up. This is for the first time that software is leading and hardware essentially is going to catch up. And we really don't know what kind of a hardware will be dominant device. Will it be a pendant kind of a system which has been popular lately? Something like a wristband, maybe it's AR where everything is projected on top of a physical universe. Will it be fully immersive VR, or will it be something which will whisper into your ears? We really don't know what kind of a software will be the delivery mechanism, and we are trying to force fit our prior desktop era interfaces and thought processes there. And if, on one hand, we don't know the answer of this question, and on the other hand, Mr. Musk is coming up with neural interfaces. So we don't even know whether actual potential of AI will be delivered by any physical hardware or some kind of a neural interface, Neuralink and all. So yeah, the first challenge is on the hardware level. And everything will manifest in next 5 years, my uninformed guess is. Now, on design system level, we essentially have breakdown of metaphor. Everything we think about in computing is we think in terms of files and processes and folders. But real life doesn't revolve around, as computing become more human-like with AI and all, the metaphor of file and desktop will break. Maybe it will evolve more about people. Think of a computer which is built around your phone book, you know, and that metaphor of desktop file will break and metaphor of place, context, human will emerge. Right now, we also think in terms of transaction, which has a clear beginning and clear end, and intermittent there are state, like, you know, committed and not committed, so on and so forth. In a non-binary world of AI, these will be episodic. Task on context will be more episodic and more continuous. So there will not be any like transaction-like system. On application layer, the challenges will be multiple. What essentially we, with the primary mode of instruction, it will be like prompt, looks like. And prompt is essentially iterative. You have to like think again and again and again, and this has to be delivered by, right now people think it's voice, which has its own affordance problem. This another challenge essentially is that everything seems to be forced through a conversational interface where machine has to respond, and we really don't know how to talk to machine. There is also a new paradigm emerging where your computer or your phone will have always on camera and they can look at your face. So instead of like doing a pinch and zoom by hand, you can like open your eyes slightly more and the interface will zoom in. Your pupil dilation can work as a, with enough high resolution camera, your pupil dilation can work as an input mechanism also. And if you, and you can stop a scroll just by like looking it in a certain way. And well, there will be a learning curve and it will not get it right in the first time, but there are more natural interfaces, you know, and machine will have to understand the emotion. That's why the emotional feedback machine will learn to process. And that change, people are experimenting a lot and it's very interesting. And on the fourth and the last is essentially about UI component. All our UI component, from radio button to checkbox to drop down to text box, everything is made for a binary world. There is no, there is only ones and zero and store as a numeral. There is no UI component we know which is dealing with a continuum, which is dealing with a fuzzy logic, you know. So we need to rethink that. So with these challenges, what happens when we subject our existing design paradigm, our existing design practices to this kind of a challenges? Well, what we see is something of a disruption in making. Empathy get disrupted. One of the most representative quote in when it comes to user empathy was Louis Sullivan's quote that form should follow the function. Well, not anymore. Now a Reddit user who on the Alexa forum says form should follow the emotion. How you communicate should follow the emotion of the user. The Alexa should respond by looking at my, not the content of my voice or message, it should look at the vibration or the tonality of my message. That becomes an input signal for Alexa. In terms of metaphor, like we talked, it moved from like file to it moved to people and places. So how a machine respond in office will be very different from how a machine respond in home or while you are driving, or when Alexa should respond differently when your dad asks something or when you ask for something. You know, and all these things, that hierarchy machine has to figure out themselves. You can't expect human to feed it these rules. Affordance. Now, again, like we said, voice is the most flexible interface. So I believe something in addition to voice should work. Maybe it's a projection screen through glasses or something. But the problem is with affordance is twofold. That if you make affordance very generic, it kind of messes with the alignment problem. Look at, if you make everything allowed, permissible in a LLM, we run straight into what should not be allowed and how to communicate it at the outset. That, yeah, you can ask any question to an LLM, ChatGPT, but this is not. Because once user asks that question and say, I'm not allowed, and the ChatGPT responds that I'm not allowed to answer this question, that's a bad user experience. You know, so how do you communicate the affordance? Feedback, again, how do you, what's the right way to communicate error message, confirmation message, tooltip, status? We really don't know, because all those constructs are made in a pre-AI world, and I'll give you an example of that. For example, we don't really know how to, if I'm 80% confirm that this is the right medicine for the symptom described by user, how do I communicate that 80%? That confidence interval, how do I communicate? And if somebody is asking what is the capital city for Portugal, and I know the Lisbon and it's 100%, should the both message should be written in the same font size, same color, same emphasis, or should be anything different? We really have no standardized answer. More than the answer, I think it's a standardization problem. Material, like we said in the very beginning, systems are shaped by the history. So we pick up the biggest cohort and we design for them and provide ladders for other cohort people to kind of learn. What is the cohort size for an LLM? Should it be the granularity of one, or should it be for everyone and anyone? We have no real answer for the granularity of cohort, because we are designing for human behavior, which human to include and which to leave. Now, the thing is, these are the challenges. Now that we know, we have to approach them with for existing thing. And that's where I would like to suggest a new way to approaching the problem. We call it intra-action. It's not interaction because we have two dynamic bodies interacting with each other. So we call it intra-action, and this is, I have no claim on this. This has been designed by an academic called Lucy Shetman, and this essentially tells when two bodies are in an entanglement and they shape each other, that kind of interaction paradigm is called interaction. So there are certain way interaction kind of manifests itself. Can we use color coding in the feedback? Can we use iterative input? Can we use like biometric signaling? So for example, can we like take your breathing pattern to your pulse, your galvanic skin response? I wear ultra human ring. It can measure a lot more data about my physical parameters, and I can use them in designing a more intuitive interface. Think of something like a task list which arrange itself based on your energy level. If you have slept well, it will pop certain tasks in the order, and if you haven't slept well, it will push certain tasks below in the order which require more energy. Can AI has the capability, but the UI is lagging in that. You know, there are things like Muse handband, which is essentially can read your brain wave, and it can say whether you are sitting idle or thinking something. And the moment you are sitting idle, can it suggest you something? Hey, why don't you call your boss, or why don't you file your tax return? You know, so these kind of a capability exists, but somebody need to stitch a UI envelope or UI kind of wrapper on around. At the same, this kind of a speculative UI is also being experimented. So let's take one part of that 6 panel grid of feedback. Can we think of, can we attempt right here to rethink the whole AI-centric interaction for one component, which is feedback? So let's say there are, right now, ChatGPT shows you everything in the same color, same font size. But not everything is designed in the same way. Let's say, take the example of recipe suggestion, medical information, dating advice, and movie suggestion. How do you color code them? Because there are different level of like determinants in that, there different level of confidence, and different costs associated with acting on those advice. If you are asking for a recipe, at the most you will have a bad dinner. So, but if you're acting on medical information provided by ChatGPT, it can be more tricky. A movie suggestion, less tricky. Dating advice, depending on your age, more or less tricky. So what we do is we basically find a 2x2 grid where we say low confidence or high confidence. If the model has high confidence on the recommendation or low, and what is the cost of action? So in case of a recipe suggestion, it's a low risk decision and model has high confidence. Maybe we should put it in the green color. Okay? In case of a medical information, what medicine to take for high blood pressure, is it orbital B? You know, so it's a high risk decision. It might do reaction or something, and model has low confidence. So maybe we should color code as red. A dating advice, should we do this on a first date or not? It's a high risk question because you have invested so much up to that point, and model has low confidence because granularity of human behavior they don't understand. So maybe tread carefully. Yellow, a movie suggestion is a low risk and low confidence because we don't really know. It's not kind of customized for you. So it can be blue. So maybe the color coding can work this way for different category of recommendation. Now the challenge here is essentially the way everyone in this world understand traffic light, can they understand the color coding? If you have to expand it to a more generic, can we simply say that every end state where something is, your order has been delivered, it turns into green. You know, this input is not accepted, error. You know, this file format is not supported, can be red. Status, your file is being uploaded, yellow. And enter your Aadhaar number, can this be blue? So basically all these kind of input can be color coded, and that will essentially convey and prepare us for that kind of a paradigm. That's like one way we can standardize it. I don't know. Let's apply this same thought process to one of the most quintessential AI example. Almost everyone, how many of you have actually used an AI companion app? Replica, character.ai, you name it. I, I don't think many will admit, but most of them have used. Yeah. So, how do you design these apps? How do you think about the persona? One way to think about this persona of user is essentially not as a partner. Most people tend to think of them as an AI companion, AI partner, but actually a right way to look at the problem is to think of them somebody who accompany you in your inner monologue. Whenever you are bored, you're talking to yourself. And this machine should be able to reciprocate or reflect back. So this machine is actually talking to as an inner monologue partner. It has a multimodal output, screen and voice both. Not only should it speak, it should have all the gesture and all the facial cues. It should have multimodal input also, which is more tricky. It should look at you with the camera and say, okay, you are not paying attention. So it should stop whatever it is saying and say, hey, you're not listening, you seem distracted. Because that's how a real human works. So it has a always on camera, which is multimodal input. It should also have a very difficult problem, which is of when to, because humans, when they talk in voice, they tend to interrupt. Every interruption require a very big mathematical calculation, whether to respond to this interruption, take the conversation into some other way, other direction, or terminate the conversation or skip. As human, we make this decision very reflexively, but for machine, it's very difficult. And the last is essentially biometric data. I know about some of the companion app where the breathing pattern of the avatar is actually based on the Apple Watch data of the user. So they mimic so much that actually the way they blink, the breathing pattern of the skeleton and all, everything reflects so you basically connect more. That's the level of granularity we have to go if we have to design for this thing. And I think this gives you a fairly comprehensive look into the challenge and the opportunity involved. See, the thing is, while this seems very challenging, this is also the only interface and the only paradigm which requires zero training. It requires zero literacy barrier. Video and voice require no, video requires zero literacy barrier to consume and voice requires zero literacy barrier to create. So if, especially for countries like India where we have a semi-literate population in an NBU, next billion user, this is going to be, it's my forecast that this is going to be the dominant interaction paradigm. And if you want to make most of it, these are the key points we have to think about. That's mostly it. I would love to take any questions. I don't. Yeah.
Actually, the Siri in Apple phones, is that nearing to the what you're talking about as
In a very limited, crippled way, yes.
Thank you, Prashant, for a very insightful session. Now I request our Swecha Secretary Praveen Chandras to present a memento for our guests.